Hello my dear students and my dear friends. Today we are again in the chapter permutation and combination, and we shall start exercise 6.2. Before starting exercise 6.2, let us try to have the concept on this exercise. Here at first we shall understand what is permutation. The literal meaning of permutation is arrangement. Suppose let us take some numbers, some digits 1, 2, 3, 4, 5. Okay, there are 5 digits we have taken. Now without repetition, now we have to frame or we have to form the numbers consisting of 3 digits 1, 2, 3. Now you can have here 1, 2, 3, suppose 2, 3, 4, without repetition 5, 3, 1. In this way, how many we can get? By the fundamental principle, we have got that the numbers we can obtain, now the number of ways are here in this place. Okay, I am explaining again here. This place can be filled up in how many ways? 5 ways. This place can be filled up in how many ways? If one digit is already taken, 4 ways. This place can be filled up in 3 ways. So total number of ways is 5 into 4 into 3. Here there are 5 digits, and out of this 5 digit we have to frame a 3-digit number using 3 digits. This is called 5 number taken 3 at a time, means 5 numbers or 5 objects taken 3 at a time, means we will take 3 times, 3 numbers we will take, but this condition is without repetition. In this similar manner, if there are n objects taken r at a time, it means, okay, at first let us try to understand this. 5p3 means 5 into 4 into 3. Okay, in the similar manner, it is n, it is in the decreasing order, is not it? N minus 1, n minus 2. How long? We shall go on how long? Okay, as there are 3, so 5 minus 0, 5 minus 1, 5 minus 2. As there are r, so it is n minus r minus 1. Have you understood? This r minus 1, okay, I'll try to make it clear. 5, this is 5 minus 1, this is 5 minus 2. Okay, this is the third place. Okay, this is the first place, so 5 minus 0. This is the second place, 5 minus 1. This is the third place, 5 minus 2. This is the first place, second place, third place. There is a relation. If it is 1, it is 0. If it is 2, it is 1. If it is 3, it is 2. If it is r, this will be r minus 1. It is r, so it will be r minus 1. In this way, this is the logic behind it. So it is n minus 1 into n minus 2 dot into n minus r plus 1. Got it? Now let us try to have a formula on it. Okay, what do we do? And let us multiply something with it into n minus r plus 1 into, if we multiply like this, n minus r into up to 3 into 2 into 1. Here also let us multiply this, n minus r into 3, 2, 1. Dear students, you can remember this. It is from n to 1. It is all the terms are multiplied. Consecutive terms in the decreasing order, these are multiplied. So what is their product? This product is obviously n factorial. And from n minus r, you see, from n minus r, it is continuously multiplied to get 1 in the decreasing order. So what is the product of it? N factorial n minus r. So by this, what we understood? NPR means factorial n divided by factorial n minus r. Please try to understand it. Okay, but dear student, there is a condition. Condition is that this r should be less than n or equal to n, but r is always greater than 0. This is the condition of it. Here this r is always maybe equal to n or smaller than n, but r is greater than 0. It means r cannot be negative. Obviously taken 3 at a time, 4 at a time, 5 at a time, but we cannot take the 0 at a time. Okay, r is more than 0. That means some object must be there. Okay, So please try to understand this formula and the condition of R. Okay. Now dear students, let us see some basic things in permutation. Already we have got this formula NPR is equal to factorial n divided by factorial n minus r. Okay. Now let us see some preliminary thing. Suppose what is NP0? It is factorial n divided by factorial n minus 0 using this n minus 0. That is factorial n divided by factorial n minus 0 is factorial n. So this is 1. Similarly, what is np1? This is factorial n. And here what will write? This minus this, n minus 1, factorial n minus 1. Now here we know that suppose factorial 6 can be written as 6 factorial 5. So here also n can be written as factorial n can be written as n into factorial n minus 1. That the next decreasing consecutive term. This is factorial n minus 1. This two will get cancelled. This is n. Similarly, what is np2? Factorial n divided by factorial n minus 2. So this factorial n can be written as n into n minus 1 into factorial n minus 2 divided by this factorial n minus 2. Now this 2 will get cancelled. Okay, so it is n into n minus 1. Okay, now we want to know what is, by the fundamental principle, what is NPN. Let us try to get one result. What is NPN? NPN means n into n minus 1 into n minus 2, like this, then 3, 2, 1. What is the meaning of it? Its meaning is factorial n. Now from this let us try to get another result. The result is that what is the value of factorial 0? We want to get that. Okay, we have here only we can discuss that. We have NPN. NPN equal to, using this, what can we write? This is factorial n divided by factorial n minus r. R is equal to here n. So n. Now what is the value of NPN? NPN is factorial n. This is factorial n. This is n minus 1 is 0. So dear students, factorial 0 means this 0 let us bring here. So it is factorial n divided by this factorial n. This two will get cancelled. So factorial 0 is equal to 1. This is another result. Okay, just one more thing I want to discuss here. What is the value of r here? R is, it is smaller than or equal to n but greater than 0. Please remember this condition. Now let us move to the exercise. Okay, now let us start question number 1. Here question is find the value of number 1. Okay, but it is 15p3. Okay, now dear student, we shall apply this NPR. What is NPR? NPR is factorial n divided by factorial n minus r. So it is factorial 15 divided by factorial 15 minus 3 is 12. So this can be written as 15 into 14 into 13 into factorial 12. We can express in this way. So this is divided by factorial 12. This 2 will get cancelled. Let us multiply 15 into 14. Then into 13. This is 2730. 2730. Next, number 2. Let us do here number 2. 11p5. This again using this we can get, this is 11 minus 5 factorial 6. So this is 11 into 10 into 9 into 8 into 7 into factorial 6 divided by factorial 6. Is it okay? Now let us cancel these two. Okay, let us multiply now. 7 is 56. This is 56. Then this is 99. Then for this 10 we shall get 55440. Okay, then number 3 it is 8p0 or 8p0. Directly we can say 1 because we know that the formula you get np0 is equal to 1. Or if you want to do, we can do in this way also using this formula, factorial 8 divided by factorial 8 minus 0 8. This will get cancelled 1. Then last one, number 4. What is that? 43p38. Factorial 43 divided by factorial 43 minus 38 is 5. Now dear students, you see from 43, then if we expand it, 43 into 42 into 41 into 40 like this, then we will get, at the end we will get factorial 5. Okay, it will be a very big number and very hard to cancel also or multiply also. So let us keep the answer like this only. Okay, now let us discuss question number 2. Show that there are 4 bits here. Let us start the first one. We shall take the left hand side. Okay, this is the sum. We shall use this formula in all the sum. Factorial n divided by factorial n minus r. Okay, so here what is NPR? NPR is factorial n divided by factorial n minus r. Is it all right? Okay, this is r into, again using that we'll get factorial n divided by factorial n minus this. What is that? R minus 1. Okay, very simple. Factorial n minus r plus this is r factorial n. So this is n minus r, minus minus plus 1. Have you understood this? Okay. Now let us simplify it further. How can we simplify? Suppose, okay, here you see, suppose factorial 6. This factorial 6 can be written as 6 into factorial 5. Similarly, this term can be written as n minus r plus 1. What is the immediate decreasing term? We shall write factorial n minus r. Okay. Now, we will take LCM. LCM, you see, this term is common. So, LCM is this into this common term. What is this? N minus r plus 1 into factorial n minus r. Correct? Okay. So, this divided by this is this into factorial n. So, this is n minus r plus 1 into factorial n plus this divided by this is 1. 1 into this is this, r factorial n. Now dear students, can you say from these two terms what is common? You can see that factorial n is common. Let us take factorial n common. What will be left? Inside the bracket n minus r plus 1, then this plus r. This is n minus r plus 1 factorial n minus r. Okay. Now here r will get cancelled. Let us write this n plus 1 ahead of this. So this is n plus 1 into factorial n. Then this one let us write. Let us arrange it a little bit. At first there is n plus 1. Here also let us write n plus 1 minus r. N plus 1 minus r, n minus r, n minus r. Okay. Now here like this. Okay, suppose 6 factorial 5. What is their product? Factorial 6. This into factorial this. So what is their product? Factorial n plus 1. We want to prove it. This is n plus 1 PR. So this n plus 1 we have got. Now this into this term, then the next immediate term. Like this, from here also you can understand. Okay. So what is their product? Suppose this is 6 factorial 5. 6 into factorial 5. 6 into factorial 5. What is their product? Their product is factorial of this. Here it is 6. Okay, I am trying to take another example. 7 factorial 6. 7 into factorial 6. What is their product? Factorial 7. So its next immediate decreasing term is this. So their product is factorial of this, n plus 1 minus r. Okay, so this can be written as, it is in this term, in this form, not term, in this form. So we can write like this. So this is n plus 1, this one p, then this n plus n minus r. Here this is n minus r. So it is r. Okay, you see, this is the right hand side we have proved. Now let us do the second one. Now we have taken the second one. Second one, let us write the left hand side. This is n into this sum. N into n minus 1 into n minus 2 p r minus 2. So this is n into n minus 1. Let us here we shall use this formula again. So what is this? This is factorial n minus 2 divided by, at first n, if it is npr we write factorial n divided by factorial of this minus this. So this factorial of it we have written, then here this minus this we shall write. Let us take the help of bracket because okay, there will be minus n, I forgot to put. So this is n minus 1, this factorial n minus 2. Okay, these two will get cancelled. So this is n into n minus 1 into factorial n minus 2. Correct. Now what it is? N minus r. Now if we multiply these three, suppose it is like this, 4 into 3 into factorial 2. What is their product? Factorial 4. So here this into this, all are decreasing in the decreasing order. Okay, so their product is factorial n divided by factorial n minus r. What it is, you can check from here. This is nothing but npr. Okay, now let us do this one, number 3. For this, let us rub it. Now dear students, let us discuss number 3. For this, it is better to take the right hand side. It is n minus r plus 1 into np of r minus 1. This is very simple sum you will find. This is n minus r plus 1. Now using this formula, what can we write? This is factorial n divided by factorial n minus of this term, isn't it? This minus this, n minus r. So n minus of this is r minus 1. Got it? Okay, so this is n minus r plus 1 factorial n. This is n minus r plus 1. Okay, let us try to expand this. N minus r plus 1 factorial n. So we can write like this, n minus r plus 1. What is the next immediate term? N minus r. Okay, I think you understood. We can cancel this. Factorial n minus r. From here, what can we get? This is npr. This is the left hand side. Understood? Now let us discuss number 4. Only this is left. Let us take the left hand side. This sum is little bit different. 1 into 1p1, 2 into 2p2 plus 3 into 3p3 plus dot plus n into npn. Dear students, here what is the concept required? Concept is we have already got what is npn, factorial n. What is, suppose 1p1 factorial 1, 2p2 factorial 2, 3p3 factorial 3. This concept we have to apply here. So let us write, this is 1, this is factorial 1, this is 2, 2p2 means factorial 2, this is 3, this is factorial 3 plus dot. In this way, if we move on, this is factorial n. Okay, now let us try to arrange this in some other pattern. This factorial 1 can be written as factorial 2 minus factorial 1. Can you write? We have written only this term, not this one. How? Do not get confused that this factorial 2 we have brought here. No, it is not like that. This term is this. How? Factorial 2 means, okay, I will show here, factorial 2 minus factorial 1. Factorial 2 means 2 and this is 1. What is their difference? 1. This is 1. Okay, then plus 2 factorial 2 can be written as factorial 3 minus factorial 2. Okay, you may be confused, no? Okay, I'll show it. I'll show that this equal to this. Factorial 3 minus factorial 2. Factorial 3 means 3 factorial 2 minus factorial 2. It is just like this, 3x minus 1x. What is the difference? Twice x, is not it? So this is 2 factorial 2. 2 factorial 2. In the same way, if we move on, we shall write, this can be written as factorial 4 minus factorial 3. Move on, plus factorial n plus 1 minus factorial n. Same manner you can check. Okay. Now let us arrange it. This factorial 2 minus this factorial 2. We can cancel this term. Okay, remember this term we shall write at the end. Let us arrange other terms. This factorial 3 minus this factorial 3. Then this factorial 4 minus the factorial 4 of the next immediate term. If we go on, then there is another term called, you see, this is the factorial 2 of the first term, then factorial 2 of the second term. Then of this term there is a preceding term, there is factorial n of here minus factorial n of that term. Let us write in that way, factorial n minus factorial n plus, and then what is left? By the way, this factorial n plus 1 is left, and this factorial 1 is left, minus factorial 1. So here everything, if you compare all the groups, this will get cancelled, this will get cancelled, this will get cancelled, all the terms will get cancelled, even here also they will get cancelled. So what is left? Factorial n plus 1 minus factorial 1 means 1. Okay, this term okay, here factorial n means npn, factorial 1 means 1p1, factorial 2 means 2p2. If it is factorial n plus 1, so what can write? np1 p np1. Okay, this term minus this one. This is the right hand side. Understood? Now let us discuss question number 3. Here question is, how many numbers between 100 to 1000 can be formed with the digits 1, 2, 3, 4, 5 without repetition of any digit? Dear students, we have to be careful here that the numbers are between 100 to 1000. So between 100 to 1000, it will start from 101 to 999. But there is a condition given. We do not have to consider all those numbers. We have to consider those numbers which will be formed using these digits. So here main thing is that we have to get 3-digit numbers, 1, 2, 3, using the digits 1, 2, 3, 4, 5. Okay, so 3-digit numbers are how many? We have to consider how many digits are there. 5 digits. Out of 5 digits, we have to take how many? 3. That means 3 at a time we have to consider. Let us use this formula. NPR. What is this? Factorial n divided by factorial n minus r. So this is factorial 5 divided by 5 minus 3, 2. Got it? This is very simple sum. This is 5 into 4 into 3 into factorial 2 divided by factorial 2. Cancel 60. Their product is 60. So there are 60 such numbers which will be formed using these digits. Okay. Let us read question number 4. How many numbers of 4 digits can be formed with the odd digits without repeating any digit? Okay. First of all, we have to frame 4-digit numbers. 1, 2, 3, 4. But condition is, what is the condition? Using the odd digit. So odd digits are, what are the odd digits? We know 1, 3, 5 and 7. Okay, now, okay, one more, sorry, I am very sorry, 9 is also there. I am very sorry for that. 1, 3, 5, 7, 9. So there are 5 odd digits, but we have to frame numbers consisting of 4 digits. 1, 2, 3, 4. So that means out of 5 we have to consider 4 digits. So 4-digit numbers are, how many are there? Let us consider. Out of 5 we have to consider 4. 1, 2, 3, 4. So let us use this formula again. NPR, factorial n divided by factorial n minus r. So this is factorial 5 divided by factorial 5 minus 4 is 1. Let us expand it. 5 into 4 into 3 into 2 into 1. This is also 1. 1 will get cancelled, or if we do not cancel, no matter. So this is 3 to the 6 and 12, 20, 120. So there are 120 such numbers. Okay. Let us read question number 5. How many odd numbers of 5 digits can be formed with the digits 0, 2, 3, 4, 5 without repeating any digit? This is a 5-digit number. 1, 2, 3, 4, 5. but they have given us a condition odd numbers. We know that a number is odd number. For that we have to look at the digit in the unit place or digit in the ones place. If digit in the unit place or ones place is odd, then only the number is odd. But here there are such two odd number digit. So we'll have two cases. First case, second case. 1, 2, 3, 4, 5. 5 digit number. In the first case, the unit place digit is 3. In the second case, it will be 5. If we put 0 to 4 here, that will not be an odd number, that will be even number. So there are two choices here, either 3 or 5 or both. Okay. Now, we have to, by the help of principal counting, let us do this. Now, this remaining 4 places, how can we fill up? Let us write. Okay. Considering, so there will be two cases, we have to write two cases. Considering 3 in the unit place or ones place, also you can write ones place, the remaining 4 places can be filled up by how many ways? Okay, you see the digits are 0, 2, 3, 4, 5. Okay, here 3 is already taken. We cannot put 0 here. We cannot, again I am repeating, we cannot put 0 here. Okay, because if we put 0, it is no longer a 5 digit number, it will be a 4 digit number. So 0 we cannot put. So either we have to put 2 or 4 or 5. So these places, this place can be filled in how many ways? 1, 2, 3. 3 ways. Okay. And this place can be, suppose 4 is chosen, suppose. Correct? This place can be filled up in how many ways? 1, 2. Here we can put 0. So in how many ways? 1, 2, 3. 3 ways. Suppose 0 is chosen. This place can be filled up in 2 ways. Suppose this is chosen. This is in 1 way we can choose. This is the digit. This is not the number of ways. So it is, how will do? 3 into 3 into 2 into 1. 18. Now let us move to the second case. Again, considering 5 in the unit place, the remaining 4 places can be filled up in how many ways? Okay, this is the digit, not the number of ways. Again, the digits are 0, 2, 3, 4, 5. This digit is already put here, so we cannot take. Again, we cannot put 0 here. Okay, if we put 0, it will not be a 5 digit number. So 0 we cannot put. So this first place can be filled up in how many ways? 1, 2, 3 ways. Okay, suppose 1 is chosen. You can put 0 here. So this place can be filled up in how many ways? 1, 2, 3. 3 ways. Suppose this is chosen. This place can be chosen, can be filled up in how many ways? 1, 2. 2 ways. Suppose this is chosen. This place can be filled up in 1 way. So the number of ways are 3 into 3 into 2 into 1. Their product is 18. So question is, how many odd numbers? So total odd numbers are, let us write, odd numbers are how many? This is the case where the unit digit is 3. So such 18 numbers we can get. And if we put 5 from the given condition, 5 in the unit place, the such odd numbers are also 18. So total there are how many odd numbers? 36 odd numbers. Okay. Now dear students, we have taken question number 6. Let us read the question. Without repeating any digit, how many 3-digit numbers, 1, 2, 3, can be formed with the odd digits? With the odd digit, we have to frame all those 3-digit numbers. But we have how many odd digit numbers? Let us write. Odd digits are, what are the odd digits? 1, 3, 5, 7 and 9. So how many odd digits are there? 5. 1, 2, 3, 4, 5. Out of 5, we have to consider 3 odd numbers. So 3-digit odd numbers are, how many are there? Let us count. Out of 5, 1, 2, 3, 4, 5. Out of 5 we have to take how many? 1, 2, 3. So 3 at a time. Let us use this NPR, this formula. Factorial n divided by factorial n minus r. So this is factorial 5, 5 minus 3, factorial 2. We can expand it. How? 5 into 4 into 3 into factorial 2. This is also factorial 2. We can cancel them. This is 60. So there are 60 such odd numbers. Okay. My beloved student, we have taken question number 7. Let us read the question. How many different words with or without meaning can be formed by the letters of the word Monday, M-O-N-D-A-Y, beginning with A and not ending with Y? Okay. Here, how many letters are there in this word? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let us count those numbers which begin with A, considering A at the beginning. Let us see how many words we can form. Now, there are six letters. But how many positions are there? 1, 2, 3, 4, 5. So, these 5 places can be filled up. How many ways? Factorial. Okay, this is factorial 5 ways. 1, 2, 3, 4, 5. Beginning with A, number of words are, how many we can get there, as there are 5 places. 1, 2, 3, 4, 5. 5 places. So in the factorial 5 ways we can arrange those letters here so that we can get in factorial 5 numbers of words, okay, which begin with A. But here there is another condition given, not ending with Y. What we'll consider, we'll do in another way. We'll consider such number which begin with A and end with Y. Let us consider. That means 1, 2, 3, 4, 5, 6. A and Y are there. A is at the beginning, Y at the end. Let us count how many such words are there. Beginning with A and ending with Y, the number of words are, how many are there? You see, out of 6, 2 places are already filled up. So how many places are there? 1, 2, 3, 4. 4 places. These 4 places can be filled up in how many ways? Factorial 4 ways. So this can be done. That means the words, number of words which start with A, end with Y, there are how many words? Factorial 4 words. Okay. Now this is just like a case. In a school, in a class, there are 40 students. 40 students. This is just an example. Okay. 30 are boys. How many girls are there? Obviously we will say, sir, 40 minus 30, that is 10. So here also, total number of words beginning with A are this. Number of words beginning with A, ending with Y are this. But how many words are there beginning with A but not ending with Y? That is this minus this. That is factorial 5 minus factorial 4. So let us say, right? So number of words beginning with A but not ending with Y are this minus this, factorial 5 minus factorial 4. So this can be written as 5 into factorial 4 minus factorial 4. 5 factorial minus 1 factorial. Okay, this is like this. 5x minus x. How much? 4x. 5 factorial 4 minus 1 factorial 4. What is the difference? 4 factorial 4. 4 factorial 4. Let us expand it. Factorial 4 means 4 into 3 into 2 into 1. 4 for just 16. 16 6. 96. So in the 96 ways are there or words are there which will begin with A but will not end with Y. Okay,